After 5 years and hundreds of millions of kilometers, the Juno spacecraft finally reached Jupiter on July 4, 2016. It fired its engine, slowing down to be captured by Jupiter's immense gravity, a triumph for science and engineering. Juno's first images were breathtaking, revealing Jupiter's poles up close for the first time. Instead of neat bands, we saw swirling cyclones, storms larger than Earth, churning in chaotic, beautiful patterns. These weren't just clouds, but complex chemical storms of ammonia and other compounds, driven by heat from deep within. Juno's mission was more than taking pictures. It was designed to peer beneath the clouds and uncover Jupiter's secrets. Each close orbit brought Juno through intense radiation, gathering precious data and sending it back to Earth. This data is like a letter from another world, revealing Jupiter's formation, structure, and history. Juno's daring journey marked a new chapter in our exploration of the cosmos. It's a testament to human curiosity and our drive to understand our place in the universe. Every pass brings us closer to the origins of our solar system. The story Juno tells is just beginning, a story that connects us to the very birth of our planetary neighborhood. With each discovery, our sense of wonder grows. Jupiter, once a distant giant, now shares its secrets with us. Why send Juno to Jupiter? The big mystery: what's hidden deep inside the gas giant? Unlike Earth's solid core, Jupiter is mostly hydrogen and helium. So does it have a solid center, or is it gas all the way down? The answer reveals how planets are born. One theory, core accretion, suggests Jupiter started as a solid core that pulled in gas, while another proposes it formed quickly from collapsing gas and dust. If Jupiter has a dense core, it supports the first theory, if not the second. Juno's mission: find out what's at Jupiter's heart. This isn't just about Jupiter. Its gravity shaped the orbits of other planets and may have protected Earth from impacts. Understanding Jupiter's formation helps us piece together the story of our solar system's origins. Juno was sent to find the first chapter of that story, written in the heart of a giant. The answer would change our understanding of planetary history. Jupiter's secrets are the key to our own beginnings. That's why Juno's mission matters. How do you see inside a planet you can't touch? Juno uses gravity as its guide. As Juno orbits Jupiter, scientists track its speed and position with extreme precision. Imagine rolling a marble over a hidden landscape. By measuring its speed changes, you can map what's beneath. Juno is our marble, and Jupiter's gravity reveals the hidden structure below the clouds. Tiny changes in Juno's speed, caused by denser or lighter regions inside Jupiter, are the clues. Over many orbits, Juno builds a detailed map of Jupiter's gravity field. Scientists use this map to determine if there's a dense core or if heavy elements are mixed throughout. It's like performing a CT scan on a planet, using gravity instead of X-rays. This method lets us probe the heart of Jupiter from millions of kilometers away. It's a remarkable feat of engineering and physics. Juno's gravity science is unlocking secrets we could never see otherwise. Human ingenuity turns the invisible into knowledge. Juno's gravity data shocked scientists. Jupiter doesn't have a small solid core, nor is it all gas. Instead, Jupiter's core is fuzzy. Heavy elements are mixed with hydrogen over a vast region. Imagine stirring sugar into tea. Instead of a lump, the sugar spreads out. Jupiter's core is like that. This discovery upended our models of planet formation. What caused this fuzzy core? One idea: a colossal collision with another forming planet early in Jupiter's history. Such an impact could have shattered a compact core, mixing it with surrounding gas. This suggests Jupiter's youth was violent and chaotic. The finding forces us to rethink how giant planets form, not just here but around other stars. Fuzzy cores might be common, and giant impacts may shape planetary systems everywhere. Juno's simple question, does Jupiter have a core, has opened up new mysteries. Science is a journey. Every answer leads to deeper questions. Jupiter's fuzzy heart is a clue to our cosmic origins. The story of planet formation is more complex and more fascinating than we imagined. While Juno orbits Jupiter, Mars missions face different challenges. Mars's thin atmosphere makes landing incredibly difficult. Parachutes alone can't slow a heavy rover. Engineers call it 7 minutes of terror. A spacecraft must slow from 20,000 kilometers per h to zero, using heat shields, parachutes, and rockets. The landing sequence is fully automated. There's no time for help from Earth. Once on the surface, Mars's thin air offers little protection from radiation and wild temperature swings. Dust storms can engulf the planet, blocking sunlight and threatening solar-powered rovers. Exploring Mars is a test of engineering and endurance. Each planet presents unique challenges: Jupiter's radiation and clouds, Mars' cold and dust. Solving these problems pushes technology forward. Every mission adds a piece to the puzzle of our solar system. The diversity of worlds demands creativity and resilience. That's how we learn and survive on new frontiers. Exploring other planets teaches us about Earth too. Our climate is shaped by the gravitational pulls of our planetary neighbors, especially Jupiter and Saturn. These tugs cause slow cycles, Milankovitch cycles, that drive ice ages and warm periods. Changes in Earth's orbit and tilt, influenced by other planets, alter how much sunlight reaches different regions. Even Venus plays a role in these long-term cycles. The great ice ages were triggered by these gentle gravitational whispers. Earth is not isolated, it's part of a dynamic, interconnected solar system. Studying planetary orbits helps us understand our own climate's history and future. The cosmos shapes our world in subtle but profound ways. We are part of a cosmic neighborhood, not alone. Our story is written in the stars and planets around us. Our solar system is on a grand journey, orbiting the Milky Way's center every 230 million years. The last time we were here, dinosaurs roamed Earth. As we travel, we pass through spiral arms, dense regions where new stars are born. These regions can compress the sun's protective bubble, letting in more cosmic rays. Increased radiation could affect Earth's climate and cloud formation. Gravitational disturbances from nearby stars or clouds might disrupt the distant Oort cloud, sending comets toward the inner solar system. Such events could trigger mass extinctions. Our journey through the galaxy may shape life on Earth in ways we're only beginning to understand. The history of life is connected to our place in the galaxy. Studying our cosmic voyage gives us perspective on our past and future. We are passengers on an epic journey through the stars. To understand our present, we must look to our violent past. The moon's cratered surface preserves the scars of a chaotic early solar system. Apollo missions brought back rocks that revealed a period of intense bombardment. Earth was hit even more than the moon. These impacts shaped our planet, boiling oceans and melting crust. Earth's own history is harder to read. Erosion and plate tectonics erase ancient craters. Scientists search for clues in ancient rocks and deep mantle samples. We found evidence of the giant impact that formed the moon and the asteroid that wiped out the dinosaurs. These discoveries show Earth is a survivor of cosmic collisions. Our world is not a gentle paradise but a product of dramatic events. Studying the moon and ancient Earth reveals the long, tumultuous story of our planet. The past shapes the world we live in today. From Jupiter's storms to Mars' dust, our exploration reveals a universe more complex and beautiful than we imagined. Juno's discoveries challenge our ideas about planet formation. Mars missions push our engineering limits. We've learned our climate and history are tied to cosmic cycles and impacts. Each discovery adds to the story of our origins, connecting planets, ice ages, and the search for life. Yet mysteries remain. Why is Jupiter's core so fuzzy? Did life ever exist on Mars? Are there other Earths? These questions drive us to build new spacecraft and explore farther. Exploration is about understanding our place in the universe and protecting our fragile home. Seeing Earth as a pale blue dot changes our perspective. The frontier of space is a mirror, reflecting who we are and what we can become. The journey has only just begun.